Hi, guys and ladies. Welcome back to another episode. My name is Lisema Matsietsi, and today on episode 4, we're looking at what is data analysis and we're comparing that with business analysis. I'm assuming that we were able to listen to episode number 3. In episode number 3, we tried to talk about what are the things that you can do, 10 actually, that you can do, 10 things that you can do to help you start your career in data. And on this one, what we're trying to do is, I'm assuming you already absorbed everything and you took a step back and you asked yourself, what type of analyst will I become? Will I become the quantitative, which is the one that's dealing with data and numbers, or will I become a qualitative, which is the one that's dealing with probably words, strategies, and type of that, more like politics analysis, economic policies? What type of analysis will I become? And on this video, I'm assuming you have decided to go with the one that deal with numbers, as is the most common one. That's what we're going to be talking about. What do we go for? What in there? What is data science? What is business analyst? Please stay tuned. We'll discuss that just after our theme song. To my surprise, I always thought that data science could be anything as long as you are dealing with the type of algorithms that you are dealing with, as long as you are writing using the same software and you're writing code on the same tools as anybody else. Why wouldn't I be classified as a data scientist? But to my surprise, I was quite wrong and I didn't know about the confusion. It was later in the organization that I used to work in that my mentor and a chief data officer at the time was in a podcast that we were sharing as employees when she hammered on the point that there's a lot of people masquerading as data scientists. And her point was it's because data science has become fashionable and it's in high demand based on the type of work that is required from this data scientist. I thought to myself, what does she mean to say people are masquerading as data scientists? She says, upon understanding what a person does and what a person knows, you can easily identify if a person is a data scientist or just a business analyst or a business intelligence analyst, that is. And I thought to myself, oh, I need to actually start to take a step back and really understand what is she talking about. This bothered me for a long time until I decided to go online and look for something else that can actually explain what data science is further. Like most people, I went to LinkedIn, I went to the free online sources, and I listened to people on YouTube videos, and I just couldn't get the grips on it. It was until later that I decided that, you know what, let me go rather and start enrolling in a course from the Corporate Finance Institute. Of course, it makes sense because I'm from corporate finance. Then I understood that, oh, actually, there is a huge difference. The certificate that I was looking at, it was called Data Science and Machine Learning Fundamentals. And it was through this that I really started opening up my eyes. And the best part about it, this was a free version of the course. So it was, when you start the course, there's those free versions that you can go through to try out if you're gonna love paying for the full course. It was one of those. So if you want, feel free, you can actually go in and explore the course yourself. It was when I opened up this, it actually helped everything else become quite clear and I understood what the difference was. So let's start first by looking at what is business intelligence and what is data science. The best answer I've received thus far about the difference is that BI looks at the history. So BI is all about understanding who, where, what do they do, for what purpose, everything else that has to do with understanding what has happened That is BI. Data science on the other side, it makes use of the data that the BI is already working on. Let's call it descriptive data. Makes use of descriptive data, but they're not dwelling on what happened in the past, but they're dwelling on how could we mitigate what's going to come in the future, or how could we predict or make estimates about what's going to come in the future. So if we put it in plain simple, business intelligence is looking at the past or descriptive data or descriptive analysis, while data science is probably looking at prescriptive and predictive analysis. Before we go on there, I know I'm throwing in a bit big words here and might be confusing if you are for the first time. Let me just also take another step back and try to explain something. The tools that I use both on BI and data science could be the same. You can write the algorithm or the code the same way. The only difference is, are you going backward? Are you trying to understand how did Lisema get to this point where he has so many subscribers? Or are you trying to predict based on his upload of episodes and podcasts how much subscribers will he have by next year's June, July, December type of a thing? The difference, if you're looking at how did I get to this point thus far, you are dealing in the realm of descriptive analysis, which is business intelligence. If you're going into predicting the future or making a forecast, you are now in the realm of data science. So just to put it clearly, there are four types of analysis that are available. And in any of these four, you would understand that there is either a business analyst or a data scientist could be best suited for any of these four. The first one is descriptive analysis. That's the one that I've spoken a lot about, and that's the one that I said it actually looks at backward. We're looking at things like who, when, how, why, all those type of analysis, where we try to understand what has transpired before we go on further with our analysis. The second one that we're looking at is predictive analysis, where we're actually looking at what is the best way that can happen for the future. You know, we're not just looking at who, where, when, how many, or what, but in predictive analysis, we're actually going further. We're like, oh, hang on a second, what is about to take place? We go that further. The third one that we're looking at is diagnostic analysis, where in diagnostic analysis, we're just sitting and trying to understand what might have happened, what might happen in that place. You understand when did things go wrong? How did it go wrong? Let's understand those diagnoses. And the fourth one, which is the last one, is the prescriptive. That tells us about the best way of mitigating that risk. How should we do it? It's more like going to a doctor and getting a prescription, because it's prescriptive analysis to say if you want to avoid this future or the current reality in the future, this is what you must do currently to make sure that you mitigate that future. So, with that being said, let's start with the first one, descriptive analysis, because it's looking at backward who, when, how many, what, when, why. Those are best for business analysis. Second one, predictive, because they're looking into the future, is 1 point for data science. The third one, which is diagnostic analysis, just understanding why is things happening, could be both for business intelligence and both for data science. The fourth one, which is looking at prescriptive analysis, is actually quite suited for data science. So out of the four types of analysis, the business intelligence come with only using two, which is descriptive and diagnostic, while data science can come through with using three, which is predictive, diagnostics, and prescriptive. And I know because diagnostic, both the data science and the BI share into it. If I was a manager with budget, I would rather work on placing a business analyst, business intelligence analyst, because they are a little bit more cheaper to do diagnostic analysis than to actually put in a data scientist in there. But it all depends on what you are trying to solve. So it's not um, it's not a standard for everybody else to follow. It is just my personal preference. to say instead of putting a data scientist in this, I would rather just put a business intelligence analysis. Let's go back a little bit and then also talk about once these two jobs, what type of skills or knowledge do they both have? So if we talking about the type of things that you must know, and you're putting them into three different buckets. Okay, the first bucket being they need to know statistics and analysis. So you know a lot about statistics and analysis on bucket one. On bucket two, you have computer science and coding, a lot of computer science and coding. And on bucket three, you have domain knowledge. When you put them all together, where these things meet, where statistics and analysis meets computer science and coding, and it meets domain knowledge, that becomes the area for data scientists. The skills that they have, they must be able to know and do data wrangling and do all of those things, statistical probability, all the things that we spoke about in episode 3. They must be able to do that because all of that relates to statistics and analysis. Data scientists should be able to do that. But why I'm creating this episode number 4 and I want to hammer on this is it does not just stop there. I had thought earlier that it stops there because we all know statistics and analysis, we should all be, say, data scientists. But no, it doesn't stop there. Data scientists also know computer science and coding. This is the, I know when I'm saying computer science and coding, you're thinking, oh, isn't that what programmers are supposed to be doing? That is correct. Data scientists also must know programming languages that most programmers are also writing on. If your organization does a lot of C sharp or C or Java or whatever the programming language that they normally do, what the coders are doing, data science will also be doubling on that, depending on whatever language that you want. A third thing is domain knowledge. If you are in fast moving consumer goods, a person who's a data scientist should know how fast consumer moving goods industry operates. If you're in financial services or you're in banking, the data scientist should know front and back end from writing a loan all the way to capitalizing or doing corporate financing. You must know everything, including treasury. How do they work? That allows them to actually have much bigger, better advantage. But I do know that when it comes to domain knowledge, not everybody would know everything. But what matters is if we're talking about sales analytics for unsecured products, the data scientist should be well adversed with knowledge of that space. Now, what happens if you only have 2 and not 3 of this? Would you still qualify as a data scientist? My quick answer is this. Let's just make an example here. You first have statistics and analysis, which is the first bucket, and you put that one with domain knowledge. You have statistics and analysis, you can do all data manipulation, you can do all of that big data, you are well versed with that, writing code, databases, you're good with that. And you have domain knowledge, you know who to contact, why did they do that system, who was there before, why did we choose on that, you know all of that. Where would you be? Would you be a data scientist? Unfortunately, you won't be. You would be a data analysis. You'll be a data analyst. A data analyst, which could actually still doubling into business intelligence analysis, depending when you're taking it into visualization. And this is where insights are coming in. If you are working on statistics and analysis and you're working on domain knowledge, you are very well a good data analyst that can actually, the insights that you are bringing from there will be business intelligence related insights. Now, what happens when you have the two, which are you have domain knowledge, you know everything about the company, you know everything about the team, you know everything else about the future, you have domain knowledge. But then you combine it with coding, domain knowledge, and computer programming or computer science and coding. Will you become a data scientist or a business intelligence analyst? No, unfortunately, you won't become. That is where you become a good software developer. I know software developing is not in this part of our matter for today, but I'm just trying to show you that if you have a very, very good domain knowledge to say what happened, what was here before, why are we doing this, and you know how to code, you are a very good person to help us solve those problems by creating applications that we can use to solve that. Maybe there might be insights in there, but your area of expertise lies on developing applications. Now let's do another one, the last one. You have very, very good statistics and analysis, and you have very, very good coding. Let's look at that. You have very, very good statistical analysis, and you are extremely good in computer science and coding. Can you become a data scientist? Unfortunately not. You cannot become a data scientist, of which you can masquerade as a data scientist, but you cannot. The best person that you could become is a machine learning specialist, or in our case, you can be a robotics process automator, because that's what you are good at. Let's say, for instance, I'm good in coding, and I'm very, very good with data, but I got no clue about the industry that I'm working on. So all the time, I need to be in a team or in a project where there's a subject matter expert who's going to tell me how things work. So in this case, subject matter expert can come in and say, can you help us? We are irritated about sending out emails, and I can actually program a robot to actually be able to send out emails. To whom should the email go to? Why shouldn't it go to this person? Why should it go to that one? Why? All of that detail I don't have to worry about. All I have to do is just machine learning. But when you're talking about the data scientists, the reason why they are highly in demand is because they can do statistics and analysis. They can do computer science and coding, and they have domain knowledge, and they bring that all together, and you create this thing called data science. But unfortunately for business intelligence, as much as we can code using the same language, it's somebody else who's got very, very good statistics and analysis and very, very good domain language. They don't have to know all the coding, computer science and coding skills. So somewhere along the line, like myself, I realized that the fact that I took a route that did not include computer science, it made it difficult for me to actually say, oh, with my degree, I can become a data scientist. No, you have to spend some time in the business that you want to be in, and you have to spend some time with data analysis and statistics, and have computer science as the core. Then you become very, very good data scientist. I think I'm just giving it out there to say computer science, big data, and spend some time at work or learning about whatever the business is all about makes you a very, very good computer science. And it takes a bit of a while. Another thing that I found out that can actually send red flags, whether you're a computer scientist or not, is the process that you follow when you have a problem before you give out your insight. There's a process that you follow. And you can just hear when you ask somebody else questions, especially in the interview setup, if they do have a process in mind, because what they'll do is they'll give you answers from all over the show. If they give you structured answers that actually ticks the process that they follow, you would get a good sense of, is this person a data scientist or not? Okay, before we go on about the process, let me just explain the process. It had 5 steps. The first step, it's all about data collection and storage. So the first thing that you do, that's the one that we've spoken about and alluded to in episode number 3. You should be able to collect all the data, whether it's going to be Excel, it's going to be Power, or whatever the case is, flat files. You collect that, you'll be able to process the data, and you're able to store it in databases. So that's the first thing. First step that you do is you are told about what the problem is, you start collecting the data, and you start storing it. The second step that you follow, you start transforming the data for projects. So for instance, you are told that we need data about unsecured products. So you can't just go and get all the data about all unsecured products. You start to say, okay, what type of product am I looking for? Am I looking at credit cards as an unsecured product? Then you go into that and you start preparing that data and transforming the data for your project. You say, oh, my project is we have to deal with credit card fraud predictions. So I have to go collect all the data that has to do with this information, and I have to prepare it accordingly so that I can use it for my project. The third step that you're looking at is doing a statistical and predictive analysis, where you could do that by building up a model. You'll hear a lot about people building models, data models in softwares like SES. Others do it in Oracle. Others are doing it manually using SSIS. Others are doing various different model building tools that are out there that they are using to build a analytical model. So the third thing is to create this predictive analysis by doing that model and putting in algorithm to spot patterns within data. The whole point about a model is to spot a pattern in data. So when I was in one of the banks and I was a activity-based costing specialist, my job description had to do with building finance models that take all the data, we push it into SES, and SES we put some rules in it to say when data comes through from this account allocated in this, use this whatever allocation rules, and then it created a predictive model to say, okay, if that's the case, this is what your transfer pricing should look like, and this is how the transfer pricing will grow and do all of those. So we have created very, very good award-winning predictive models or activity-based costing models that were one of the best in Africa. So that's what you do on number 3. Number 4, what you do is the thing that you do the most is you evaluate your model and then you start your data visualization. So the model that you build on step number 3, you come over, you put some, I don't know if you want to call it stress testing it, but you need to start testing the model to say, okay, I can see we have a model about how to split transfer pricing. You take the total cost, you split it this way based on either volumes or based on activities that people are doing or based on whatever means of splitting it out. And then what you do is you take that same model and then you throw in fresh data and you see if it's still going to use the same percentage split. You take the same model, you use a different maybe cost center and you throw in the data for the different cost center. You just test the model to see can it actually withstand whatever it was built for. So that will be step number 4. It's a model evaluation. And when you do a model evaluation, it's quite good that you already do visualization of your data, of you haven't started coming to an end, but you just visualizing to see, is this thing operating in a way that we had thought it was going to operate. The fifth and the last step is when you start sharing your insights. So you don't share your insights immediately when you get your first output. When you get to step number 5, you have done all this the testing. You have already have a few visualizations that are coming out. Here, this is where most of us are sitting and we love it, where we start writing memos and nice articles about what does it mean for us to have a resilient model or predict the risk of whatever in the future. This is where it comes in. That's one small craft that you put it there with a little line that says, this is what today looks like, and this is high road, low road, and middle road going into the future. It's all based on what did you do when you get to the 5th model. So I hope this video this conversation gave you more or less what's the difference between business intelligence and looking at data science. There's a huge difference. And it all has to do with not just the language that you are coding or the model of the computer that you are using or the type of access card that you are using to walk into the organization, but it has everything else to do with where your domain knowledge lies, and also it all depends on the process that you follow. You can follow the same process, but if you don't have the right skill set in terms of what do you know, domain knowledge or statistics or analysis, or a little bit of coding. If you don't have that, I'm sorry, to break it down to you, but I don't think your skills are allocated to data science. There might be more for other things like software engineering or stuff like machine learning or even business intelligence. Finally, when I got this information through this online course, then I really understood what our CTO was saying when she said, you have to find out what the person is through a series of questions. Now I know those series of questions are the ones that you ask until you find out what domain knowledge the person sits on and what process do they follow. Thanks guys for watching. We're going to be having a discussion again on episode number 5. Episode number 5 will be taking a little bit deeper on business intelligence. See you on the next episode.